In this short class we're going to review types of research approach. Now this material is covered in other videos in the classes, and those approaches are much more elaborate and more extensive. This one is a short video summarizing the main approaches. So we'll start with a quantitative approach. Now, as the name suggests, this uses data in quantitative form. This can be subjected to rigorous quantitative analysis in a formal and rigid fashion. In other words, it may use data that's collected, quantitative data, numerical data, and subjected to statistical analysis, quite sophisticated statistical analysis, perhaps using sophisticated computer programs to derive insights into the data and see what the data is saying. The inferential approach. Now the inferential approach is looking at the data to try to infer characteristics of the population. So if a sample is taken, say, from the population, then the characteristics of the sample are worked out. Perhaps let's say the mean of the sample is calculated, and from this the mean of the population is inferred. So it's an inferential approach, and the mean of the population, of course, may not correspond precisely to the mean of the sample. So it may be that it's the sample mean plus or minus a certain percentage equals or gives you the interval in which the population mean will fall. So it's trying to infer population characteristics from a sample, and that's generally what statistics is attempting to do, in fairness. The experimental approach, this involves greater control over the research environment, and some variables are manipulated to observe their effect on other variables. So that would be an experimental approach. It's generally used in the natural sciences, for example in physics or in chemistry, where there are many variables and the scientists try to control many of the variables and vary one of the variables and see what happens to a second one. So it's trying to control the situation and isolate out what they're interested in, which may be the effect of one particular variable on another. So it has to hold everything, all the other variables, constant. And I appreciate that holding a variable constant doesn't sound right. Next, we have the simulation approach. The term simulation in this context means that instead of looking at the business, it's looking at a simulation of the business. It's looking at a design which is similar to the business. It's looking at situations that are similar to the business and trying to work out what would happen to the business if something was to change. So it's normally used in business and social sciences, and it normally refers to some numerical model that represents the structure of a dynamic process. In other words, it's normally some sort of model which is an idealization of the real situation. It's some sort of model, and then the model is allowed to change, which will simulate what would happen in the real situation. So it's a simulated approach. It's looking at a model and looking at what will happen to the model if certain situations arrive. Now, the easiest way to conceptualize this is to consider, let's say, architects. And I know that's not in business or in social science, but consider architects who design a skyscraper. They make a model of the the real skyscraper. It may be a scale model, and then they may subject it to all sorts of weather conditions or earthquake conditions to see what will happen if such an event was to arise with the real skyscraper in place. So they're simulating what would happen. And in business, it's possible to simulate situations as well. Normally computers are used, and computers use random numbers to try and generate all sorts of situations, and it gives an insight into how robust the business model is. The model uses the values of initial conditions, so it starts off from some initial state, and all the parameters to represent the behavior of the process over time are included. The simulation model involves the construction of an artificial environment within which relevant information and data can be generated. So it's looking at an artificial situation, a model, and then runs the model under various conditions, and then suggests that in the real situation, if those conditions were to arise, certain outcomes would follow. It permits an observation of the dynamic behavior of a system or its subsystem under controlled conditions. So it's possible to work out what would happen to the real situation if certain events happened. So it's a simulation. It's useful in building models for understanding future conditions. Finally, we can look at the qualitative approach. Now, this is concerned with the assessment of attitudes and opinions and behavior. And these are not easily measured, but they are important nonetheless. The fact that they can't be measured doesn't mean that they're not important. But it's important to work out what determines attitudes and opinions and behavior. It could be an attitude towards changes in a product design, or what are the opinions of customers about the product or about the strategy of the business. And it uses a variety of sources of information. For example, it may use focus groups, or it may use interviews or in-depth interviews. Interviews which really probes what was meant by certain answers. So the qualitative approach is also used and is very important. Now, as I said, it's a short video. I've just highlighted here some of the main types of approach, and these are covered in other videos in much more detail. But for the moment, that's all I want to do in this situation, in this particular video. So we're going to leave it at that and say thank you for watching.